Welcome to The Explainer. I am absolutely thrilled to have you here today. Listen, if you've spent any time working with data, you already know that how you store it can literally make or break your code. So today, we're mastering the absolute core of navigating Python's primary data structures: lists, tuples, and sets. By the end of this explainer, you're going to know exactly which tool to reach for, no matter what kind of coding challenge comes your way. Okay, let's dive into this. Store, organize, use smartly. This isn't just some catchy phrase. It is the fundamental rule and the absolute foundation of all efficient coding in Python. You can have the most brilliant logic in the world, right? But if your data is stored in the wrong structure, your program is going to be slow, clunky, or just completely broken. We really need to be smart about how we organize our information. So here is our roadmap for today. First, organizing data in Python. Then we'll check out lists, the changeable workhorse, followed by tuples, the immutable vault, and sets, which are for unique items only. Finally, we'll wrap up with the ultimate quick comparison. Starting with Section 1, organizing data in Python. Python is incredibly generous. It gives us these distinct, highly specialized tools to handle data, but picking the right one is absolutely crucial because it directly impacts your memory, speed, and functionality. Moving right into Section 2, lists, the changeable workhorse. Let's start with the structure you are probably going to use the most. I honestly like to think of the list as the friendly, everyday workhorse of Python programming. It's flexible, it's reliable, and it's basically always ready to adapt to whatever you need it to do. By definition, a list is an ordered collection that is changeable, and the fancy programming word for changeable is mutable. I really want you to lock that word into your mind. Mutable. It means you can change the contents incredibly easily after you create it. Think of it exactly like a flexible grocery list. You write down what you need, but while you're at the store, you can cross things off, add a new item at the very bottom, or just swap out one brand for another. The list just adapts to your immediate needs. Visually, lists are defined by their square brackets. Take a look at this syntax. We have a variable called fruits, and we set it equal to square brackets containing apple, banana, and mango. Because lists are an ordered collection, every single item gets a specific numbered position called an index. And remember, Python starts counting at 0. So if you want to access that very first item, apple, you'd use fruits bracket 0. Banana is sitting at index 1, and mango is at index 2. Now, since lists are mutable, Python hands us this massive toolbox of methods to modify them, and a few of these really stand out. You're going to use append constantly. It simply adds a new item right to the very end of your list, like, say, adding orange to our fruits list. If you need an item in a specific spot, you use insert, giving it the index and the item. To take things away, you've got options. Remove takes out the first occurrence of a specific item, like banana, but pop is incredibly handy. It removes an item at a specific index, or if you just leave it blank, it pops the very last item off the end and returns it to you. You can also organize your data super easily, using sort to alphabetize, reverse to flip the order, and lent to instantly find out how many items are currently sitting in your list. So lists are incredibly flexible with those square brackets. But what if you don't want flexibility? Like, what if you need absolute certainty that your data won't get changed by accident? Well, let's contrast the highly mutable, changeable nature of square bracket lists with our next, much stricter data type. Section 3, tuples, the immutable vault. Now, what's really interesting about this slide is we are shifting from complete flexibility to a completely locked-down state. See, a tuple is an ordered collection just like a list. But here is the defining difference. It is unchangeable or immutable. That is an absolute non-negotiable rule. Once a tuple is created, you cannot add items, you cannot remove items, and you cannot change the items inside it. Whatever you set on day 1 is exactly what stays there forever. Let's quickly break down the core features. Tuples are ordered, so they use the exact same zero-based index system as lists. But they are immutable. Think of them as literally having a heavy-duty padlock on them. Now, you might be wondering, why on earth would I use something so restrictive? Well, because that strictness actually makes them process faster than lists. Python knows the size and contents of a tuple will never change, so it optimizes them for speed. Oh, and to tell Python you want a tuple, you simply use round brackets, parentheses, instead of square ones. Moving on to Section 4, sets, only unique items. So we've seen flexible, we've seen strict. Now it's time to introduce our third contender, which are basically the ruthless bouncers of Python data structures. A set is an unordered collection of entirely unique items. Sets have two major rules. First, they completely ignore order. There's no index 0, 1, or 2 here at all. The items just exist together in a pool. Second, and honestly most importantly, sets absolutely forbid duplicates. If you try to hand a set a group of numbers like 1, 2, 2, 3, that set instantly drops the extra 2. It's only going to store 1, 2, and 3. Duplicates simply are not allowed to exist in a set. No way. Visually, you can spot a set immediately because it uses curly braces. So when you see nums equals 1, 2, 3 wrapped in those curly braces, you instantly know you're dealing with an unordered pool of unique items. Because there's no index, we obviously can't use methods that rely on position. Instead, we manipulate the items directly. You can simply add an item or remove an item. But the real magic of sets comes from mathematical operations. You can combine two different sets together using union, which returns a brand new set containing all the unique items from both. Or you can use intersection, which looks at two sets and returns only the items that they both have in common. And this brilliantly illustrates exactly how those mathematical methods work. Look at the union, or A union B. It completely includes both circles. It grabs absolutely all items from both sets, the whole shebang. But then the intersection, A intersecting B, only filters for the overlapping middle section. It tightly filters the data to give you just the common items. So if set A is 1, 2, 3, and set B is 3, 4, 5, the union is 1, 2, 3, 4, 5. But the intersection is just 3. It's an incredibly powerful way to filter data. All right, Section 5, the ultimate quick comparison. We've explored the changeable lists, the lockdown tuples, and the unique sets. Now it's time to bring all three of these data structures together side by side for the ultimate showdown. So the crucial point is this master key matrix right here. Let's run through it. Are they ordered? Lists and tuples are a yes, meaning you can use index numbers. Sets are a no. Are they mutable? Lists and sets are a yes, meaning you can add and remove items. Tuples are a hard no. Do they allow duplicates? Lists and tuples say yes, sets say no. And what about the syntax? Lists use square brackets, tuples use round parentheses, and sets use curly braces. Honestly, if you only take away one thing from this entire explainer, let it be these three rules of thumb. Use a list when order and changes matter. Use a tuple when your data is fixed and you want to protect it from being altered. And use a set when you absolutely need to guarantee that you only have unique items or if you need to do fast mathematical comparisons. I absolutely love this quote from our source material. Practice today, code better tomorrow. You know, understanding the theory is step one, but opening up your code editor and actually trying to append a list, unpack a tuple, or find the intersection of a set, that is where the real learning actually happens. So, I'll leave you with a real-world scenario to test your new knowledge. Imagine you're building a network application. You need to store a fixed directory of secure server IP addresses. This list absolutely positively should not be altered while the program is running. Based on everything we just covered today, which structure would you reach for? Think about it. Trust your instincts and happy coding.